We want to find the vertical and the horizontal asymptotes for the given rational functions. So I'm going to start with the first one and find the vertical asymptote first. Now to find the vertical asymptote, the rule is very simple. All you need to do is set the denominator equal to 0, and whatever value of x you get, let's say x equals to some constant, this is your vertical asymptote. So for example, in this case, let's set the denominator equal to 0. X squared minus 4 equals 0. This would mean that x squared is equal to 4. If I take the 4 over to the other side by just adding 4 to both sides of the equation, and if x squared equals 4, then taking square root on both the sides, you get x equal to either positive or negative 2. So the vertical asymptotes for the graph of this function is x equals 2 and x equals negative 2. Okay. What about the horizontal asymptote? Now the horizontal asymptote has different rules depending on what the degree of the numerator and the degree of the denominator is. So if you refer to the rules in your notes, you'll see that, let's look at the degree of the numerator and denominator. In this case, the degree of the numerator is 1 and the degree of the denominator is 2, which means that the degree of the denominator is greater than the degree of the numerator. So in this case, the degree of the denominator is greater than the degree of the numerator. If this is the case, then we say that the horizontal asymptote is just the line y equals 0, or the x-axis. And this is because as x keeps increasing, you'll see that this function, as x keeps increasing, as x goes towards infinity, your f of x, let's call this f of x, goes towards 0. Now for the second part, in the exact same way for the vertical asymptote, you just set the denominator equal to 0. So we set x minus y times x plus 5 equals 0. Now this could mean one of two things. It would mean either x minus 1 equals 0 or x plus 5 equals 0. So that means, this means that x is equal to positive 1, and this means x is equal to negative 5. So these are your vertical asymptotes. As for the horizontal asymptotes, we want to look at the degree of the numerator versus the degree of the denominator. Now this is a little tricky. If you look at the degree of the numerator, x squared, so the degree of the numerator is 2, and if you want to look at the degree of the denominator, well, you'll see that there's an x term here and there's an x term here. So if I was to multiply this out, you would get x squared minus x plus 5x minus 5. So in this case also, you'll see that the degree of the denominator is 2. So what happens in a case like this? If the degree of the numerator is equal to the degree of the denominator, then the rule is that your horizontal asymptote is y equal to the leading coefficient of the numerator over the leading coefficient of the denominator. Okay, what do these terms mean? So if you look at the leading coefficient of the numerator, it's the term associated with the highest degree, that's 3. And for the denominator, well, once we multiply this out, we see that the leading coefficient, there's really nothing there, but that means that the leading coefficient is just 1. So in this case, this is going to be y equal to 3 over 1, or just y equal to 3 is the horizontal asymptote. Okay, and then for part C, once again we want to find the horizontal asymptote and the vertical asymptote. So for the vertical asymptote, It's very easy. All you need to do is just set x minus 17 equal to 0, denominator equal to 0, and that means x equals to 17. So that's your vertical asymptote. As for the horizontal asymptote, okay, now once again we look at the degrees of the numerator and denominator. You see that the degree of the numerator is 3 and that of the denominator is 1. So in this case we see that the degree of the numerator is greater than the degree of the denominator. If the degree of the numerator is greater than the degree of the denominator, this means that there is no horizontal asymptote. So if the degree on top is greater than the degree on the bottom, then there's no horizontal asymptote.